Yeah.
here. That's one way to describe it, horizontal. Do you remember the slope of a horizontal line? It's a special slope.
No, I don't.
Okay. This is not great on a few levels. The first is that like this is basic algebra knowledge that's important to know for not just this course, but for others. Um, so it's maybe a brush up on some of that at some point would be good to do here. But the slope is 0. Um,
Oh,
okay, the slope of a horizontal line is 0 here. Okay, let's move on to so it says here, at which temperature does the slope first change? First changes at 0 degrees. Like normally it is going up and to the right, it's increasing, but then it stays flat. And then it's asking like what's happening at the temperature. You've actually already answered it. What does it
it's
say here
melting
that's
the
happening?
ice.
Yeah, so could you give me a sentence in the chat um, that says that? It's always good if you can reuse some of the words. Uh, like at this temperature, it's word, some words, but up to you. Full sentence.
Got it. All right, I just typed it in chat.
All right, yeah. So it completely starts to melt. Good. All right. So now number 4 says describe what the added heat energy is doing to the molecules of water. So they're basically asking for your understanding of molecules and melting. Like what could the molecules be doing to cause it to melt? And maybe think back to that video we watched on the molecules moving around.
Um, they like okay, from the video when they were moving around, the first time they were all hitting each other, but the second time they weren't.
Right. So uh, the heat energy causes the molecules to speed up or slow down.
The heat's causing them to speed up.
Okay, so that would be a good thing to write here. A sentence that says what you just told me about the molecules speeding up.
All right, I just typed it out.
When adding heat, the molecules, the water are speeding up. Okay, seems okay to me. All right, good enough. So question 10 says, at around 2 minutes, yeah, grab the graph. Make it a little smaller. All right, so at around 2 minutes, the slope of the graph changes again, right? It was flat here, horizontal. and the changes. So let's take a look here. What does this tell you about the status of the change of state? So what they're trying to tell you is that in this first increase, it was solid ice, completely solid ice. Then it's liquid water. This is melting. So there's some of both. But what happens when it hits this up slope here? What happened to the water or to the ice?
It becomes water.
Okay, so let's get a sentence that says that it changed from one state to another, and be specific about those states, please.
All right. Would this work like the way I typed it out?
Okay, so you didn't at all include the word state. Um,
Oh,
you
I
didn't,
forgot.
you've not included the word liquid water. You have talked about ice melting. Um, you may want to talk about solid ice.
All right. So what I say like the state of change of solid ice becomes liquid water after it melts. Could I use that?
Yeah, that sounds pretty good.
All right, there we go.
Okay, we'll go with that. All right, now we can answer this question about what does positive slope mean in terms of temperature change. So notice where the starting temperature is when it's liquid water. What's the ending temperature where it's liquid water?
It says like the temperature when it becomes liquid water is about but like 50 degrees. It's in between 60 and 40, so I would assume it's 50.
This is liquid water is referring to everything in this region here.
Oh, so from like it's liquid water it starts from 40 to 100 degrees, so any those
It, it
temperatures,
it starts at 0 degrees. That's where it first starts increasing, and it
right?
goes all the way up to 100 degrees. So the question isn't written really well. I think what they're trying to get you to say is something about how liquid water increases in temperature pretty rapidly.
Okay.
And I would probably try to say exactly that in what you write now, that the temperature of liquid water increases pretty rapidly.
Should I say like the temperature of liquid water increases rapidly after the ice melts?
Yeah, that sounds good.
All right, just there we go.
You left out the part about ice melting.
Oh, I thought you didn't want me to. Oh, no, sorry, I didn't understand. Should I say solid ice or just ice?
It's redundant to say, like it shouldn't. They're doing it to because of the state of matter is solid, but ice is considered a solid. So the point, it doesn't really matter. Everyone will know what you're talking about. Kind of
Okay,
like
then
when
I
you say
just.
straight line, like everyone knows what you're talking about, but it is an unnecessary word.
All right, I won't mention solid ice and I'll just write ice. There we go.
All right, good. Okay. All right. This is the question is about the graph between 4 and 8 minutes. I feel like we've sort of already done this in terms of down here at the ice melting. How would you describe the slope from 4 minutes to 8 minutes? How would you describe the slope of this line?
So at 4 minutes, the liquid water's at 100 degrees. And then to 8 minutes, the water just is boiling
In terms
still.
of the graph, though, how would you describe the slope, either as a number or as a word?
It's a, I can't say straight line because all of them are straight lines, but it's a very long, in my opinion, I think it's the second longest line on the
The
graph.
length doesn't really matter. What did we say about the slope in this ice melting region?
It starts at 0 because it's a horizontal line,
Yes, the slope is 0. So there's actually no temperature change. The slope is 0. There is no temperature change.
right?
Okay. All right. Give me a sentence that describes what's happening in here.
For the 8 minute mark.
In between 4 minutes and 8 minutes.
Okay. So I've written so far at this temperature, the water is starting to boil, and I should say the temperature is staying the same while the slope's at 0, right?
You could add that the temperature is staying the same. Yeah, that sounds good.
Okay.
Okay. So we've we've actually answered question 3 here earlier, like what's happening to the molecules. Let's go back and look at that answer. When adding heat, the molecules in the water are speeding up. Do you think they're speeding up more rapidly or less rapidly compared to the ice melting?
The molecules are moving extremely fast, I assume, when water's boiling.
Yes. Do you want to say that? Like, yes, they're
Yeah.
they're being added to it. They're heating up. They're increasing in speed. You can even say they're more rapidly.
All right, there we go.
So you're not necessarily going to be this answer could be a problem. If I look back and I grab your previous answer, and this is just the thing that instructors want to see. They want to see that you're using their words. Are you using their words
No,
to answer the? Okay,
let me rewrite that then.
okay.
So like, would this work? You're not seeing the. I guess I didn't make it clear enough. You have to say added heat energy. Like I would want to see that in my answer, just like you did before. Um, Okay.
but like you don't have to change your answer that you had before. You just have to maybe say
Mention heat
speeding up
energy.
even faster,
The
even
molecules are
fast.
heating up and increasing their speed energy.
Well, you can. My point is, you can use the same answers before. You just might want to say it's even faster compared to the ice melting. That's it. Okay, let's look at question 12 at around 8 minutes, so right here again.
Okay.
And really this is very similar to being down here, which means you can reuse that answer, but you should maybe slightly reword it because it's not solid ice, it's different this time. So let me put that in the chat and maybe you can reword it to answer this new place.
Okay, wait. Around the 8 minute mark, it also so I should mention the fact that the water starts to boil after 8 minutes, or should I say that the water starts to vaporize?
I would follow the template you have here instead of
Okay.
saying change from solid ice to liquid water, it's going from liquid water to vapor steam after it boils.
Okay.
I'm just trying to get you to reuse what you already have.
Yeah, that's what I'm doing. I changed from like how the state of change instead of putting like I changed solid ice to liquid water and then it starts to boil after 8 minutes.
Okay.
Then I don't know what like can I send you what I have so far?
Well, what I hope you have is exactly what's written here with, I'll just change the words that you need to change. That needs to change. That needs to change. That needs to change. Like you're just changing the words to match this new scenario. So if you haven't changed all those words, maybe take another look at it and see. That point there at 8 is exactly the same as that point there at 2, but just different words.
Got it. Would this work?
Let's step it in. All right. Of liquid water starts to become vapor steam. Okay. So let me temperature of boiling water increases rapidly. It starts. So it's yeah, this does work. You only had to change the words. I mean, you added in a little bit extra here, but it looks like it'll be okay. Probably better. It's not exactly the same anyway. All right, so we're done with that, but there are still 4 more questions, 3 more questions on states of matter. All right, so there are 4 states of matter to consider. You probably already know 3 of them. So let's take a look. Solids, they're
Liquids and gases.
the gases, yeah. So you probably already know that there's this idea that of the shape. So solids have a definite shape. Liquids do not have a definite shape, but they can assume the shape of the container that it's in. Okay. Particles are different. Gas particles are different. They fill a container, but then they will leave it just as quickly as they go into it if it's not sealed. The last one is plasma. All right. Um, it's found in lightning bolts, stars, and signs and all that. It's created very high temperatures, and I don't truly know much about plasma. It doesn't have a definite shape or volume. It's more like a gas in a lot of ways. All right, so to answer these next questions here, the ones that are difficult to compress are, how do I want to word this? The are the ones that have a definite shape. So if it has a definite shape, it's hard to compress. Think of well, trying to think of an example here, but compressing means to almost remove volume from it. So let me help out here. The answer to 13 is solids and liquids. Can you give me a sentence that reuses some of the words in this question for that? And
Sure.
then we'll talk about how to answer the next part of it.
So like, okay. So I rewrote like the beginning of the question, but I said the states of matter that are difficult to compress. Should I then mention the solids, liquids, and gases?
Only solids and liquids.
Okay, that's what I wrote right now.
Okay, so the reason that they are difficult to compress is in the case of solids, they already have a defined shape. And in the case of liquids, they can take on a defined shape. You could also mention that the particles are closer together. So you can use this to provide your answer. Please use some of the words in this question here to answer it, like we've been doing.
Can you repeat that one more time?
How much of that do you want me to
Just like
repeat?
just like the last few parts.
About starting with solids having a defined shape?
Yeah.
Okay, so solids have a defined shape. You can think of anything that you're looking at in wherever you are right now. A solid has a defined shape. Liquids take on a defined shape when they're enclosed inside a solid. Like if you're drinking water, if you don't have the container, it will just spread out everywhere.
Right.
And one of the reasons is because the particles are closer together. So I'm asking you to answer this second question. Explain why they are more difficult to press in terms of the particles in these states of matter. You can include anything here that I've written, but I'd like you to also reuse some of the words from the question here as well.
All right. Should I mention the fact that for solids that like sometimes with if they're in like a container they don't expand, but if they're taken out of a container they will start to expand?
You
Or
can, I mean, we're talking about mostly the particles. The big thing here is that the particles are close together and you cannot change their shape, which is why they're difficult to compress. Compressing means to change the shape.
got it. Okay, here's what I wrote.
Right. So grab this here. They are more difficult to compress because it's in size and solids always have a defined shape. Particles try to get some hard to compress. Yeah, that's looks good. Go with
Yay.
that. All right. Which states of matter are easier to compress? So gas and I guess plasma. Really don't think I really don't know much about plasma. So I think it's just gas, and it's essentially the opposite of the answer above here, which is that they don't have a does not have a defined shape. Particles are moving around rapidly, something like that.
Okay.
Um, there you could also add in there is a lot of space between the particles.
Okay. All right, here's what I typed.
All right, let's go with that. Looks good. Okay, so I want you to take your best guess at, and these are just one word answers for numbers one, two, three, and four here. Solid, liquid, gas, plasma. Give me your best guess for each of these.
Yep. Okay, I just kept saying solids and liquids for each of them because they're the only ones I think that could that came to my head for each question. But like, let me just double check before I sent them in.
The answers are not solid liquid for everyone. If
Yeah,
that
that's
helps, but
why I'm double checking.
just choose one for each.
Yeah, I just in 1 and 3, I feel like solids are the only two ans are the only answers for those two.
Okay.
Yeah. Okay, here's what I wrote out for the answers, and we'll see.
Right. So number one is definitely solids. Number two is definitely gases. Number three is solids, and four is also liquids. So you got it perfect. All
Let's
right.
go.
All right. So we're just gonna do one word answers. Hopefully that's okay. All right. And then liquids. Okay. I feel like I maybe double check here. The only thing that I know is there's more. I'm sorry.
There's
Oh
more.
boy, it's three more. I thought we were done with this. It's the thing
I
that
thought we
never
were done
ends.
too.
Describe in detail what happens when you add heat to a solid at its melting point. Um, you've kind of already done this, so I don't know why you have to keep answering this. This is basically the discussion of what we had. I don't have the graph. Let me grab the graph again. Hang on.
This is a great time.
Um, let me grab the graph again. All right. Um, so when we look at this graph, asking about what's happening down here and um, at like where it started, the horizontal line. So they're saying what happens when you add heat? Well, we know that the particles start moving more rapidly, but the temperature does not change. And then slowly, 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 the state changes altogether. So that in its answer, they're looking for you to talk about the change in states from solid to liquid, ice melting, um, and then also that the temperature does not change.
All right. Okay, here's what I wrote for number 16.
All right. So let's stop there for now. And we'll pick up here with question 17, which basically the same question, but asking about this region of the curve here. We'll be able to finish 18, and then we will work on whatever else you want us to work on. So we'll go ahead and
Alright,
stop here, and I'll see you in about 10 minutes.
see you in 10 minutes.